All right. Build fast, but don't break things. These are shapes. Trapezoids represent artifacts. Rectangles with arrows represent nouns, or not nouns, verbs, actions, things that change things. Actions have inputs and outputs, and actions might have inputs that are chained to further actions to produce an input artifact, an output artifact, with some intermediate artifacts in there. You might have multiple intermediate artifacts, and critically, you might have multiple artifacts that are inputs to an instruction that creates a final output artifact. So you might be looking at this and you're like, that's a directed acyclic graph, right? Well, you're right, but we're not here to talk about theoretical computer science. What are we here to talk about? Docker. Yep, this is another Docker metaphor. And this here, these instructions, that's what you're looking at when you're looking at a Docker file. Let's talk about OpenEdX and building a Docker file for OpenEdX. So in Tutor's OpenEdX Docker file, we start with a base image running Ubuntu 20.04, and we install system requirements into that to create an intermediate container. And we're just going to ignore those intermediate containers for now. They're just our intermediate artifacts that are going to be feeding into our further instructions. Then we take an application repository, edx-platform, we all know and love, may love. We take that as an input and install Python packages from it to create another intermediate container. From there, we install node packages. And lastly, we build and collect static assets to generate an OpenEdX Docker file. And from there, you can deploy that to the cloud, or if you are trying to change OpenEdX, you can run it in Tutor or run it in DevStack if you are building a DevStack image. We're done, right? Thank you. No, just kidding. Things are always changing. We're constantly changing the edx-platform application repository, especially if you're a developer. You're making changes all the time to add unit tests, fix bugs, add features, and that's going to affect the Docker file you're using. And when a change happens, what do? Do we just throw away the entire Docker image we just built? No, that's a huge waste of time. Rather, we want to make the smallest, most targeted change we can to the Docker file, or to the Docker image based on our Docker file. And how do we decide what has changed, which actions need to be rerun? We follow these arrows in our directed acyclic graph. So we start with the changed artifact, follow the arrows down to the instructions that have that artifact as an input, follow it through any intermediate artifacts, all the way to the final output. And those artifacts that have been affected by that flow of dependency is what we throw away. And then we rerun any instructions we need to regenerate our outputs. And importantly, we can skip anything that hasn't been affected. The base image didn't change. We don't need to reinstall system requirements. And if you're thinking, well, I don't build my Docker images. I usually pull them down. I usually download them from Docker Hub. Well, this affects you too, because those Docker images you download, they're not big monolithic rocks that you download at once. These are not virtual machine images. Images are built in layers. And those artifacts that we destroyed earlier and had to rebuild, those are exactly the layers that we would have to download if you're downloading the image instead of building it. And again, importantly, the parts of the image, the layers of the image that haven't changed are cached on your machine. So depending on the change you make, you might be downloading the entire Docker image, or you might be downloading some of the Docker image. And this makes a huge difference and isn't something we're always perceptive of. Great, right? Well, we can do better. Any change to the application, the edx-platform repository in this setup represents a lot of destroyed intermediate artifacts, which is either a lot of rebuilding or a lot of waiting on downloading. And let's say all we have changed is like a CSS file in edx-platform. If you look at those instructions there, it wouldn't make sense that we would need to reinstall Python packages or reinstall node modules. All we would need to do is rebuild static assets. And in this current setup, we're rerunning those top two instructions, installing Python and installing node packages. We're rerunning them for no reason. So how can we refactor our Docker file? Well, let's take our input, which is one big input artifact for edx-platform, and slice it into smaller input artifacts. We can individually use the Python package list as an input, the node package list, everyone's favorite package-lock.json, and the source code as 3 separate things. So looking at that, let's say we have a change in the source code, change in the source code. All we need to do is follow the arrow from that, which is building and collecting static assets and configuring a startup command. We don't need to reinstall Python packages. We don't need to reinstall node packages. Much better. And this brings us to the dual mandate of someone who's trying to write a good Docker file. Or really, it doesn't have to be Docker. This is like any container image system. Firstly, it has to be correct. If a change happens, you need to rebuild the parts of the image that are affected by that change. Otherwise, when you run that in production or in development, people are going to be confused, or people are going to think the site is broken, because it is broken. But secondly, if we can achieve that, let's do it as fast as possible. If we can still be correct by only rebuilding the things we need to rebuild, let's do that. Let's be efficient. Build fast, but don't break things. So we have moved from a monolithic, big rock automated build to a layered automated build. Much better. But can we do better? Well, let's look at these 2 input artifacts, Python package list, node package list. Any change to the Python package list results in a reinstallation of node packages because of this intermediate artifact here that's chaining them together. And even if we switch those 2 as inputs, then we have the opposite problem. Any change to the package-lock.json results in a reinstall of Python packages. So in either of these cases, we're wasting some time. So what can we do? Is this just a fact of life? Do we have to choose an order here? Well, let's think. Let's put on our thinking caps. And let's make the text smaller. And let's rename these so we're keeping track of them a bit more. I hope you can see them. If not, it's just base system, Python environment, Python node environment, and a full system. And, oh, look, we have all this space on the slide. Let's move those over. And let's move them over some more. This is the same graph, just bigger and moved around, but it's same arrows and everything. Right now, this is running in series. Install Python, and then install node packages. Let's do it in parallel. Install Python and install node packages, and then merge those environments together. Is this something we can do? Yes, this is something Docker lets us do, as of 2017, actually. This is called a multi-stage build, and it's a fairly recent feature in Docker that makes it a lot easier to build efficient images with Docker. And this graph here brings us about to today. This is a pretty realistic, simplified but realistic version of how we build Docker images today, if you ignore some very important things like configuration, theming, custom Python packages, and translations. But if you forget those, this is about what it looks like. And all those things I listed there, that we take this same idea into account when writing a Docker file around those. But, I mean, we don't talk about how fast OpenEdX images are to download, do we? No, we don't. We could be doing better. So this is one thing the Developer Experience Working Group is working on, particularly this little instruction here, build and collect static assets. It can take 10 plus minutes, and that's on a pretty powerful laptop, and with a pretty good internet connection. So without those things, it could be even more. So like changing the node package list understandably results in a rebuild of static assets in our current graph here, but so does changing the Python package list, and so does changing any bit of the edx-platform source code. And even if we take the edx-platform source code and break it into 2 pieces, we break it into the front end and the back end parts. Even changing the back end source code results in a rebuild of the static asset build. Why is that? Well, it's because for legacy reasons, the static asset build process for edx-platform involves a mishmash of different technologies, both front-end and back-end technologies. We require Python tools, a Python environment, in order to build static assets. And this is something we're trying to undo. We're trying to rewrite the static asset processing pipeline for edx-platform in just standard front-end tooling, glued together with some bash. And if we have that, once we have made that refactoring, we'll be able to take this, cut this unnecessary dependency, cut that unnecessary dependency, and we end up with a much more efficient Docker file. Any change to the Python package list only results in, the only thing that would result in a rebuild of the static asset build is a change to front-end source code. Much better. More time writing code, less time downloading. Build fast, but don't break things. Thank you.